Hello, welcome to Crystal Core Skills. Today we are going to continue with the last part of our similarity and congruence by looking at some of the conditions for similarity and congruence. So we are going to take a look at the conditions that we need by combining similarity and congruence to decide whether two similar shape are really similar and congruent to one another. So in the previous video, we learned that similarity deals mainly with the study of the shape of an object, and congruence adds one additional features to the shape, which is the size. So congruence help us to learn about the shape and the size, whereas similarity just deals with the shape. So we are going to see the part that lies between the combination of these two in order to allow us to be able to say that two objects are really congruent and similar to one another. So the first condition is what is known as SSS, which stands for side. This condition defines actually a triangle, because you can see SSS means side. So a triangle is defined by by three vertices and three angles and three sides. So SSS simply means that when we have a triangle like this and we have another triangle like that, let's say this is triangle ABC, that one's ABC, and let's say this is our triangle A and that one is our triangle B. Now, to apply the SSS constraint, we need to ensure that this triangle have the sides. As you can see now, they're similar in terms of shape, and they have the side. Let's say this is side 1 and that is side 2, and that one is the third side. Now, when this one has three sides like that, the other triangle also has to possess similar kind of features, that it has side. So when we have two triangles like these with similar side, we say that these triangles are in fact similar. And to make it congruent, you just need to assign some size by giving the length to the side of the triangle. Maybe you can just say this one is 6, this one is 8, this one is 9, and then the same length has to be replicated on the other side as well, regardless of whichever side you choose. But as long as the quantity of the sides are the same, it doesn't matter. Or you can even leave it like that, because this one is enough to say that these triangles are really similar to one another. So when we create the quantity for the side, we make it even more, make similarity even more stronger, because from here now we can say triangle A is similar and congruent to triangle B. The second condition is actually AAA, which stands for angles. So this one is indicating the three angles in a triangle. Let's say this triangle A, and we have angle there, angle there, angle there, so that each angle is assigned AAA, so that we can have three angles in a triangle. Now, if you have a similar triangle with three angles like that, let's say this is triangle B with vertices A, B, C, A, B, C. If we have a triangle like that, then we say these triangles are in fact similar, because all of them have three angles. And the orientation of the angle matters in this case. For example, if you have 60 degrees here, 60 degrees also has to be here. And let's say 40 degrees there at the apex of the one triangle, that 40 degree has to be replicated here as well, so that we can have our 80 degree there, 80 degree there. So we can say these two triangles are similar or congruent to one another. So triangle A is similar and congruent to triangle B. This is a special case though, because you can jeopardize this constraint by, if you introduce some other shape to either of the triangle, you will obviously ruin the constraint, which will make this one not meaningful. For example, if you try to extend this shape, maybe you extend this side of the triangle, extend the other side, and you come up with some sort of straight line, and you will come up with all the corresponding angles. And then when you take one triangle, you can have big triangle and a small one. You will find that the angles will vary at some point, and that will obviously ruin the integrity of the congruence. And we don't want to introduce something like that unless you want to prove that it is possible to break the principle of congruency. Then you can go ahead and do that. But we need to restrict ourselves to specific triangles so that we can prove and show that it's possible for two triangles to be similar just by assessing their angles. The third case is ASA, which means that we need angle, side, angles. So SSA, as long as we can have a triangle like triangle A and then another triangle B with two sides, and let's say with two angles, not two sides, because we are dealing with ASA, which means angle, side, angle. So we need two angles to enclose one side in the middle. So we have one angle there and then another angle there, so that our side becomes that side there. You see, because we have only one side. So the angle will be A, angle 1, and then side, and then angle 2, which is that one. So if you have the same kind of feature in that triangle B with the same side, the side could be anywhere as long as it's between the two angles. Let's say angle A, angle B. Now, let's say A, so that we maintain the rules ASA, but obviously this is triangle A, B, C, triangle A, B, C. So ASA means two angles and close one side in the middle. So two angles and close side, and two angle and close side there. So we can say that if two triangles possess this common feature, then they are in fact similar and congruent with one another. Especially when you give the triangle now the angle, let's say 60 degree, 40 degree, 40 degree, 60 degree. You don't necessarily need to give the angle, but just to maintain or to show that they are congruent, you can just say triangle A is similar and congruent to triangle B. So the fourth condition is SAS. This is the fourth condition, and it simply means that when we have two triangles, this one is obviously side, angle, side. So when you have two triangles AB with the side ABC, ABC, BC, as long as we can have two sides, we can identify two sides in these triangles, we can say that they are similar. And one angle has to be in between the side like that. So when we have the two sides and the angle between them in each of the triangle, we can say that these triangles are in fact similar. Now, we want to also emphasize the congruency part, which we need to assign some, which requires us to assign some size. So you can put the side there, side there, side there, side there, and the angle there. You can just give some quantity if you like, but you can leave it like that because we are mainly dealing with the the relationship between these two angles. So if you want to make it perfect, that's when you can assign the quantities there. And in this case, we're just going to do it for the sake of meeting the condition for congruence, so that both similarities and congruence conditions are met. So we can say this side is 5, this one is 6, this one is 5, and this one is 6. So that we can have triangle A being similar and congruent to triangle B. So my friend, this is the end of our conditions for congruence. There could be others like, of course, like AAS, SSS A, so that you can have 5, 6 there. And when you follow the same principle, you will always prove that or show that two triangles are in fact similar and congruent to one another if they possess common features in each of them. So my friend, thank you for viewing, and I hope this video has been informative. We took a look at 4 main conditions for congruency, which SSS, which means that two triangles have to have all the sides equal. Like the side could not be equal, but as long as they have 3 sides, you can deduce from there that they are similar. And when 2 triangles have 3 angles, then you can say that they are similar because they have 3 angles. And also when 2 triangles have, let's say each of them has an angle, 2 angles with a side in between them, then you can say they are similar and congruent. And we look at SAS, which means that when two triangles have equal side and an angle and close between 2 sides in each of them, then we can conclude that they are in fact similar and congruent to one another. And also we look at other possibility. Obviously you can extend to as many conditions as possible, but they have to be true for the objects under comparison, so that you can come up with concrete relationship between them. And we also notice that it's easy to jeopardize this congruency by introducing other features, obviously, on any of these triangles. Any changes can jeopardize the congruency constraints when you introduce other shapes like line extending this shape like that. The congruency may not be maintained always, especially for the case of AAA and I would say AAS perhaps. So thank you for viewing, and I hope this video has been informative, and I will see you in the next video. Please remember to subscribe, share and comment, because your comments are very important for me to learn, because I learn from the mistakes I make as well as by sharing our views together. So I'll see you in the next video, where we're going to see how to apply all these or some of them to prove or verify the theorem, like Pythagoras' theorem in the triangle. Remember, what to take home from here is that similarity helps us to define triangles and to set the constraints for the relationship between the 2 objects. And that is the take home from this video. Thank you for viewing, and I hope this video has been informative. Thank you.